All right, welcome back. We are going to take a trigonometry subtest. So this will just give you 8 problems to practice, ACT type problems. Good luck. Hit pause. Come back when you're ready. All right, they want me to find sine of theta. So I'm standing here, label your triangle. This is adjacent, this is opposite, this is hypotenuse. Sine is so, which is opposite over hypotenuse. So sine of theta equals opposite over hypotenuse, which would be 4/5. Okay, hit pause, come back when you're ready. This looks like a cosine function to me. It is. Sine would do this. Oops. That would be sine. Tangent goes through the origin, does this. Secant, reciprocal to cosine, would do this. And cosecant is reciprocal to sine, it would do that. So it's got to be cosine. Okay, hit pause. Come back when you're ready. And hopefully you got it. Okay, it says given that theta is between 0 and 360, which means it can be anything. What is the value of theta if cosine times sine squared plus cosine cubed equals 1? Well, I always check for factoring, and both of these terms have a cosine in them. So if I factor out cosine theta, divide by cosine theta, divide by cosine theta, I get sine squared theta plus, if you take a cube cosine and you divide by cosine to the first, that leaves cosine squared theta equals 1. Well, this is 1. So now I can say that cosine theta times 1 equals 1, which is just cosine theta equals 1. Now, here's a couple of things that they want you to do. So you got to figure out what theta is. And again, in our review, this really never came up. Excuse me. You could do a couple of things. If you're trying to get theta alone, if you're trying to kill a trig function, okay, you see it, the sine key, the cosine key, and the tangent key. Above it is this, I don't know, you can't see it very well, I didn't make a very good copy. It looks like it says sine to the negative first, which means inverse sine. Above cosine says cosine to the negative first, which means inverse cosine. It's also called arc sine, arc cosine, and then arc tangent. And what those keys are for is to get rid of a trig function. In other words, if I want to get theta by itself, I need to kill cosine. Well, the only thing that'll kill cosine is an arc cosine. And you got to do it to both sides. The arc cosine kills cosine, which leaves theta alone, which is what I want. And so what you have to figure out is what is the arc cosine of 1. So, up here, not down here, if I just do second cosine, it'll do that inverse cos and it'll open up parentheses. I put the 1 inside and hit enter, and I get theta is 0 degrees. Your other option was just to type these in. Again, making sure you're in degrees. Cosine 270 is 0, not 1. Cosine 180 is negative 1, not 1. Cosine 135 is negative 0.70, blah, blah, blah. Cosine 90 is 0, and cosine 0 is 1, which is what I wanted to find out. Okay? Hit pause. Come back when you're ready. And hopefully you got H. All right, so we have secant squared theta minus 1 times cosecant squared theta is equivalent to which of the following? Well, what I happen to notice is there's a Pythagorean identity right there. All right, and if you went and looked at your sheet or back at the review, you would know that secant squared theta minus 1 is equivalent to tan squared theta. So I'm going to replace that with tan squared theta times cosecant squared theta. What am I going to do now? Well, I know that both of these have something to do with sine. Oh, so my reciprocal identity says I can rewrite that as sine squared theta over cosine squared theta. And my reciprocal identities say that I can rewrite cosecant squared theta as 1 over sine squared theta because they're reciprocals. Those cancel, which gives me 1 over cosine squared theta, which isn't one of my choices. But again, the reciprocal identities, 1 over cosine squared theta is equivalent to secant squared theta. So there's my H. Okay? Try this one, hit pause, come back when you're ready. And hopefully you got 30 degrees. So an airplane leaves a runway at an angle of theta. When the airplane has reached an altitude of 5,000 feet, it has traveled 10,000 feet in the direction it took off. At what angle did the airplane leave the runway? So again, we're trying to find theta here. Well, if I'm standing here, this is opposite to me, and this is hypotenuse, and that's a sine function. So I can say sine of my theta is equal to opposite over hypotenuse, which gives me sine theta is equal to 1/2. So you have a couple of choices here. You can do this by right triangle trig, and you can say, well, so now I know that the sine is, basically this is 1 over 2, right? And I know that if this reduces down to 1 and this reduces down to 2, all right, I could do Pythagorean theorem and say leg squared plus 1 squared, the other leg, has to equal the hypotenuse squared. So that'd be leg squared, this is 1, this is 4, 4 minus 1 would be 3. So my other leg has to be the square root of 3. So if this is my square root of 3, and I'm thinking, wasn't there something about a 1, 2 square root of 3? Well, not necessarily 1, 2 square root of 3, but what caught my eye was my hypotenuse was double one of my legs, which made me think of a 30, 60, 90 triangle, because in a 30, 60, 90 triangle, this would be the short side, this would be the long side. Whatever the short side is, the long is that length times the square root of 3, and the hypotenuse is double whatever the short is. Well, I know that my short leg is equal to 1, so my long leg has to be 1 square root of 3, and then this has to be 2x, so it follows. There's that relationship, which means that is indeed the 30-degree angle. Okay, that's, again, they're depending on you remembering your 30, 60, 90 triangle relationships. Okay, again, at this point, to me, it's a lot easier. If I'm trying to figure out what theta is, I want to kill sine. Well, that arc sine function will kill it, which leaves theta alone, which is what I want. So you type in arc sine of 1/2. And I did it on my calculator, arc sine of 1/2, and I get theta equals 30 degrees. Okay? All right, try this one, hit pause, come back when you're ready. And hopefully you got 45 degrees. Here's that other one where they expect you to remember the 45, 45, 90 relationship. If I know that secant is the square root of 2, then I know that cosine theta is the reciprocal, so it'd be 1 over the square root of 2. Follow me? Well, if I set up a triangle and put my theta here, cosine is adjacent over hypotenuse. And again, I remember that you'd have to just remember that if this is 1 and this is the square root of 2, right? In that 45, 45, 90, this is always the leg square root of 2, and the legs have to be equal. Okay? And if I did the math, 1 squared plus the other leg squared equals the square root of 2 squared. That's 1 plus leg squared equals 2, because when you square that, it kills the radical. So leg squared equals 1, so leg equals 1. Well, I know when the legs are equal, the base angles have to be, and if this is a 90-degree angle, then the only thing that can be is those are 45-degree angles. My thing is again, you have this equation. You're trying to get theta alone, So kill cosine with arc cosine to both sides. That kills it, leaves theta alone. And you type in arc cos parentheses 1 divided by the square root of 2. Sorry, that looks bad. I was going to write it sideways. Alright, and I'll show it to you on my calculator. And you get theta equals 45 degrees. Okay? Again, if you remember your 30, 60, 90s and your 45, 45, 90s, which you should. I mean, they do come in very handy, but so does a calculator. Okay, try this one. Hit pause. Come back when you're ready. Alright, it says the base of a ladder is placed 5 feet from a house. If the ladder creates a 46-degree angle with the ground, which of the following would be used to find out how high up the wall? So they're looking for this one. Well, if I'm standing here, this is adjacent, and this is opposite. And the function that uses, we have SOHCAHTOA to choose from. The function that uses opposite and adjacent is tangent, so I would set up tangent 46 equals opposite over adjacent. And then if I were to get x alone, I'd multiply by 5, and I'd get x equals 5 times tangent 46 degrees. Okay? Alright, try this one. Hit pause, come back when you're ready. This one's a little tricky, okay? They give you a variable instead of a number. Well, cotangent, if cotangent is x squared over 1, then tangent theta is 1 over x squared. And tangent is opposite over adjacent. So if I set up my little right triangle here, and I call that theta, opposite is 1, adjacent is x. Well, they want me to find secant. Secant is reciprocal to cosine. Cosine is adjacent over hypotenuse. So secant theta is going to be the hypotenuse over the adjacent. Well, oh, sorry, this is x squared. Okay, so I know that my adjacent is x squared. So the bottom has to be x squared. Okay, well, that eliminates that, and that. So now I just got to pick between those two. Well, all you got to do is Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Well, that's 1 plus x to the 4th equals hypotenuse squared, which if you wrote it properly would be x to the 4th plus 1 equals hypotenuse squared, square root. And my hypotenuse is the square root of x to the 4th plus 1, so that goes on top. And that's my answer. Okay? Alright, so I hope you did well, and I will see you next time.